You intend to estimate a population mean with a confidence interval. You believe the population to have a normal distribution. Your sample is 13. While it's an uncommon confidence level, find the critical value that corresponds to a confidence level of 88.4%. Now the fact that we're finding this for a population mean tells me that we're going to use the t-distribution because we don't know anything about the population standard deviation. So I always start with drawing a bell curve, place my confidence level in the center. I'm going to call this 0.884. And that leaves me with, for the tails, 1 minus 0.884, which is 0.116. Now, if I split that into both of my tails, then that's going to be 0.116 divided by 2 gives me 0.058 for each tail. So those would go here. 0.58 in the right and 0.58 in the left. So to double check that, you can add these three numbers together and you should end up with 1, representing the entire area under this curve. Now what we need is to find the critical value that corresponds to this, and that's going to be our positive critical value here that has 0.058 to the right. Or the same idea, the critical value will have 0.884 plus 0.058 to the left. So one way to do this, if we had a standard or common confidence level, is to go to the t-distribution table, and we would simply look up that remaining area 0.116 in the column, in the top row up here, area and 2 tails. But notice there is no 0.116 because this is an unusual or not common confidence level. So our only choice is to use some form of technology. Let's use a spreadsheet to find this. So what I'm going to do is use the t.inv function, and the first thing it asks me is for the probability. What it's looking for is the probability to the left of our t-score. So one option is to add 0.884 plus 0.058, and that will be the area to the left of my critical value, and that's what we want. So if I don't actually want to do the addition, 884, I can do the addition inside the function. So 884 plus 0.058, and that will be the probability it's looking for to the left of my critical value. The degrees of freedom now we're going to get from our sample size, which is 13. Degrees of freedom is their sample size minus 1, so that's going to be 13 minus 1 in our case, which will be 12. So I type that in here, and my critical value is 1.694. That is my critical value.